All right, so welcome. We're finding average rates of change. So we're going to find the rate of change from a graph of a nonlinear function. So this is the graph of y equals log x. Remember, if there's no base written, then it's a base of 10. All right, we want to find the average rate of change from x equals 10 to x equals 100. All right, so log 10 would equal what? So try to do it without looking at the graph. What would log 10 equal? 1 is correct. And that's because 10 to the first equals 10. All right, and it's understood the base there is 10. And then how about log 100? What would that equal? 2. Because 10 squared is 100. So here our average rate of change, we just take the difference in the value of the function over the difference in the x values. So that's going to be, so here's our 2 points, they're up here. But I'm hoping you had a little practice by not looking. So we had 2 minus 1 over 100 minus 10. So that would be 190, 1 over 90. So what a slow average rate of change that is. For one little change in y, you have to change 90 on the x. So very, very unsteep line. It's the opposite of unsteep. Shallow doesn't sound right. Log is a very slow growing function, and the greater the base, the slower the growth. Okay. Anybody need to set up? So now we're back on the other page. All right, so now sometimes you're just given a function and you're not given a graph. That's okay. You just plug in. I'm going to show you 2 ways to plug in. I'm going to show you just regular substitution and synthetic substitution. Use whichever one you like. I like to use synthetic substitution because I can do it faster. All right, so here we're going to plug in. So these are our x values. Okay. Those are x values. You're always given x values. You have to find the y values, the value of the function. All right, so f of negative 3, we can just plug in negative 3 everywhere we see an x. So negative 3 to the 4th plus 2 times negative 3 cubed minus a negative 3 minus 1. And that's going to, so this is, by the way, it's called substitution. So this would be negative 3 to the 4th would be 81 plus 2. Make sure exponents first before multiplying. So that's negative 3 cubed is negative 27. Minus a negative 3 is going to be plus 3. And then minus 1. And we can multiply there. So f of negative 3 equals 81 minus 54 plus 3 minus 1. So f of negative 3 is going to be, so 81 minus 54 is 27. Right? And then 27 plus 3 is 30. 30 minus 1 is 29. Right? And then we're going to do the same thing again to get f of negative 2. So negative 2 to the 4th plus 2 to the 2 times negative 2 cubed minus negative 2 minus 1. So f of negative 2 equals 16 plus 2 times negative 8 minus a negative 2 is a plus 2 minus 1. So f of negative 2 is going to be 16 minus 16 plus 2 minus 1. So 16 minus 16 is 0. 0 plus 2 is 2. 2 minus 1 is 1. So f of negative 2 was 1. Right? So you should put that in your notes. Now, let's look at synthetic substitution so you know the difference. My cord is, I think, stuck. Got a little bit more space. So I can only go as far as my cord stretches. All right, so synthetic substitution. Oops. Missing an E there. Oops. Now that doesn't look very good, so I couldn't line it up. Let's try that one more time. Synthetic substitution. All right, my H looks weird, but we'll take it. There we go. Oh my gosh, what is it with my spelling today? Holy cow. S-Y-N-T-H. Synthetic. Keep leaving out letters when I'm writing them. All right, so synthetic substitution is just like synthetic division. All right, you do the exact same steps. The only difference is you're not looking for it to be a 0 at the end. You're not looking to see if it's an x-intercept. You're just getting the value of the function, whatever it is. Your remainder is the same as the value of the function. So it's a nice shortcut. When you set it up, you got to make sure you represent everybody. So this is technically x to the 4th plus 2x cubed plus 0x squared, because there's no x squared. You got to represent them, minus x minus 1. So when we set it up, we'll have 1, 2, 0. The coefficient for negative x is negative 1, negative 1. And we're dividing by negative 3. So we want to substitute in negative 3. We're just doing it, instead of doing this way, we're doing it synthetically. And it is a little faster, so it takes up less space. So you bring down the 1. 1 times negative 3 is a negative 3. Add, you get negative 1. Negative 1 times negative 3 is a positive 3. And then add, you get 3. 3 times negative 3 is a negative 9. Add, you get negative 10. Negative 10 times negative 3 is a positive 30. Add, you get 29. Notice we got the exact same thing. I think it's a whole lot less work. All right, so definitely put that synthetic substitution in there so you can use that as well. All right, make sure you show that you have to change that one, put the 0 in. If you choose to use it, it's fine if you choose to substitute in, but at least you want you to know this is available and how to do it. All right, so and then do the same thing, only this time with negative 2. So we bring down the 1. 1 times negative 2 is negative 2. Add, we get 0. 0 times negative 2 is 0. Add, we get 0. 0 times negative 2 is 0. Add, we get negative 1. Negative 1 times negative 2 is 2. Add, we get 1. So you notice we got the very same answers. So most of this problem was just getting the values of our function, and this one just took a lot less time. And I had a lot less places for me to make a mistake. Average rate of change is going to be the difference in the value of the function over the difference in the x values. So our values of our function are these right here, and the same ones as we got over here. All right, those are our y values, those are our function. And then our x values are up above. Make sure you match up the correct y values and the correct x values. All right, match up. 29 goes with negative 3 and 1 goes with negative 2. So we have 29 minus 1 divided by negative 3 minus a negative 2. So that's going to be 28. Negative 3 minus a negative 2 is the same as negative 3 plus 2. So that's going to be negative 1. And this is a slope of negative 28. So that's our average rate of change over the interval. There's negative 28. Any questions on this one? The only new part is the average rate of change. The other part's kind of review. So this is, we've seen from a graph, and now we've seen from a table. And so now we're working with an equation. And the last one will be a couple real world problems. Yeah, you can see it right off of the benefit of sitting near the computer. You can read it right off the screen. Anyone need this one up? Okay. Now synthetic substitution only works with the polynomial functions, but they're the ones that take the longest to evaluate. So that's okay. So you can't use synthetic substitution if it's not polynomial. This one's polynomial. This time I'm just going to do synthetic substitution. I'm not going to do it two ways. Right? I just did that on the last one. All right, so I'm going to use synthetic substitution, and these are our two x values. And I don't even need to plug in the 0, do I? But let's plug in the other one. So negative 1. Let's see, do we have we don't have everybody. X to the 4th, excuse me, plus 2x cubed. This is the same function, isn't it? Plus 0x squared minus x minus 1. All right, so we don't have the x squared again. So 1, 2, 0, negative 1, negative 1. Bring down the 1. 1 times negative 1 is negative 1. Add, we get 1. 1 times negative 1 is negative 1. Add, we get negative 1. Negative 1 times negative 1 is 1. Add, we get 0. 0 times negative 1 is 0. Add, we get negative 1. All right, so this is 1 point here, negative 1, negative 1. The other, I don't even need to plug in 0, do I? So f of 0 is negative 1, right? It's that right there. So interestingly, they both have the same value. So same y value of the function there. So there's our other point, 0, negative 1. Any questions at all where we got the points from? And we plugged in. Right. Here I just didn't need to plug in because it's going to be my y-intercept. It's going to be the last value. All right, so average rate of change is the difference in the x value of the function, over the x values, difference in the x values. So that's going to be negative 1 minus a negative 1 over negative 1 minus 0, which is negative 1 plus 1, which is 0 over negative 1, which is 0. So the average rate of change is nothing because they're the same y values. And we're done with this one. We'll do one more problem. All right, so this is a good one to do because this is similar to one on your closing. All right, so, and we have no graph here. So we want the average rate of change of y equals log 3 of x from x equals 1 to x equals 27. So log base 3 of 1 would be, class, what's log base 3 of 1? Come on. Be brave. What's log base 3 of 1?
0.
0 is correct. Good job. That's because 3 to the 0 is 1. And then how about log base 3 of 27? What would that be? Three is correct, because 3 cubed is 27. All right, so we have our 2 points here. One of them, so this is the y, so the x values are given there. The y value for when x is 1, y was 0. When x was 27, y was 3. Right, the y values are the exponents. So our average rate of change is going to be the difference in the value of the function over the difference in the x values. So average rate of change is going to be 3 minus 0 divided by 27 minus 1. So that's going to be 3 over 26, and that's not going to reduce. So we tend to have very not so steep slopes for average rates of changes for log functions because they grow very slowly. And I'm going to put up the closing. So I'm going to end this podcast.